Hello guys, welcome back. Today we are going to study supervised machine learning, and one of the type of supervised machine learning is regression algorithm. So today we are going to implement one algorithm, linear regression, in this class. So first of all, we will understand the concept behind this linear regression, how regression works, and how you can create an algorithm in linear regression using your data set. Am I audible? Can you please clear me in chat window? Okay, shall I go ahead? Okay guys, so today we are going to see how to implement linear regression. So first of all, I'll tell you, till the last classes we have seen lots of concepts, like basic concepts of the Python, and then we have seen some libraries like NumPy, Pandas, Matplotlib. Today we are going to use all of them all together. We will use different concepts from the different libraries, and one of the most important library we are going to see today is Scikit-Learn. Like what we are going to see here, you can see supervised machine learning. You should know the concept of supervised machine learning, and then you should know linear regression, how we can implement linear regression. We will implement linear regression with the help of Python, different libraries of the Python. And there is one important library in the Python that is called the Scikit-Learn. This Sklearn, or we call it Sklearn, this library have lots of things. If you see the documentation of this library have certain data set, it have certain functions to create the algorithms, to create the models, and it have certain performance measures. So we can say this library has basic requirements like data sets. This library has certain algorithm functions, and this library has some performance measures also. Okay, so in this library we are going to see lots of things. Okay, clear guys? And you can say, when you are going to implement some machine learning algorithm, in the machine learning algorithm, the basic thing, the first algorithm comes to our mind is regression, linear regression. This is very simple, and if you understand the concept of linear regression, then you can implement any algorithm. Like process of all the algorithms should be same. But the data set and some input features, all these things we are going to change, but the machine learning concept, how the machine learning works, all these things are similar in every algorithm. Okay? Yeah, Seaborn is different library that is just for plotting. We will see one example of the Seaborn also. Till now we have completed only the 7 classes. So don't worry, I'm going to cover each and everything. Whatever we have promised to you, we are going to cover all the things. So agenda for today's class is, first of all, I'll give you a little bit introduction about the supervised machine learning. So you should know how the machine learning works and how the supervised machine learning works, and then we will move towards the linear regression. In the first class, I already told you what is the supervised machine learning. In the supervised machine learning, basically, Okay, in the supervised machine learning, basically we train the machine with labeled data. Here I'm going to use certain terms today and you guys should be familiar with these terms. So labeled data means whatever you are going to predict, you know their label. Means your input data is tagged with some input data, you have some input data. And along with input data, you have certain labels, or you can call this output data. Like if I talk about the simple example, fruits example. Okay. In the fruits example, you are having lots of fruits. So what is the input feature? Input feature is their features. Their features is shape, color, size. So here I can write like this: shape, color, size. These are the different features, and label is name of the fruit. Okay, so when you are training a model, you are teaching with the help of these features. You are giving model these features as well as name of the fruit. Like you are teaching a little child, like this is a banana, how you will tell this it have yellow color, its a size is, its a length is like this, its a shape is like this. There are lots of features we are capturing through a object, and then we will tell, first time we will tell this name of the fruit. So here we are having input as well as we are having label also. Okay, so we also call it this supervised training. Supervised means here we are having a supervisor that is telling each and everything to our machine. It is a simple thing. A student learns in a supervised manner from their teacher. So we are having input as well as we are already knowing the output also. Basically, how does it work? Let me tell you the flow. Like we are having some labeled data. That data having certain feature as well as its a label. And this label data will be fed to some machine learning model. Okay, and then we are ready with some algorithm. We also call this algorithm. Okay, and then we have some test data, and with the help of this test data we are doing certain prediction. Okay, so like here we are having different fruits like apple, banana, mango, something like this. Okay, and in the test data also we are having certain labels. So we are feeding here test data, and this model will give you the prediction output like name of the fruit. This would be this fruit. Okay, so suppose we are having 3-4 fruits, and these fruits are labeled, their feature as well as their name. So after the training, our model can recognize its name. And how the data works? Basically, data, if I talk about the data, it means whatever data we are having, we're dividing data into two parts. Like data set, data. Okay, I always divide this data into two parts, train as well as test. What is this? Suppose I am having 100 records. In the 100 records, I am having features and it's a label. Okay, so out of 100, I'll divide it into 80:20. So 80 records, with the help of 80 record, I train my model. Okay, I'll teach my model 80 records, feature as well as label. And then the remaining 20 records, what I will do? I will predict with the help of 20 records and I'll test the accuracy of my model. And I'll check either my model is giving correct output or not. Okay, guys? So basically we are having training as well as testing data set. Now come to the supervised machine learning. This is the data part. We will divide our data into two parts. Okay, and if I talk about the supervised machine learning, there are the different type of supervised machine learning. Supervised machine learning having broadly you can categorize two categories. One is the regression, okay, and another one is classification. Sorry, just a second. Basically now we will understand what is the regression and what is the classification, because we are going to implement the regression example today. So first you should know what is the regression and how does regression works. Then only I'll move towards the implementation part. Regression, in the regression we are having some input variables and some output variables. Okay, so input and output variable. We will find out the relationship between input and output variables. Like we are having a line equation y is equal to mx plus c. Here you can understand what is the m, what is the c, and what is the y. So if I talk about this x is independent variable. And if I talk about this y, this is a dependent variable. Okay? And this m and c, m is slope and c is some constant. This is line equation we all know. In the 9th, 10th standard, we study this equation. Okay, so here we are having some independent variable as well as we are having some dependent variable. So what we need to do, this here independent variable is called your feature. If I talk about in terms of machine learning, this is feature. And this dependent variable is your label. With the help of these features, we will predict label. So we are trying to make a relationship between dependent variable and independent variable. And this is always linear. If we try to plot the relationship, we also observe there would be a straight line. Some x and some y. Okay, there would be some points like this. There is some point like here, here, and something like this. So what our model will give you some line like this. So we can say relationship between dependent and independent variable is always linear, and it follows the line equation. Clear? And generally where we use this type of algorithms, we are generally using for like weather forecasting, where here we are predicting a continuous value. We can get market trends. Okay, we can get stock market trends, or you can say housing price prediction. Clear the concept? And if you have any query till now, you can ask me. Here basically we are predicting some continuous value. Whatever the value you are feeding for x, some corresponding value, numerical value, you can call it numerical value also. You are going to predict a numerical value along with this. Okay? So I can say I'm drawing this graph. So here my independent variable and here my dependent variable. Okay, and then I can draw a line here and then certain points like this. So these points called data points. These points are data points, or you can say these points having independent value here and its a corresponding dependent value is this. And this line is called linear regression, line of regression. And this constant y is equal to, here in place of mx plus c, we are generally writing a plus bx. So here a is called intercept. And this now it's a connected, don't worry guys. Okay? I'm using Geo network, don't worry about it. I'm using GigaFiber. It's not BSNL and high plan of GigaFiber, but sometimes it happens. Don't worry about all these things. Okay? Now it's working fine? Yeah, I'll repeat it. From ax plus b. Here, y is equal to ax plus b. So you can see x here is independent variable. Okay, and your y is dependent variable. And here b is coefficient. B is your intercept. And your A is coefficient. This is simple line equation, but here we are denoting by these terms. Clear? So now I'll implement some data. Or two types of linear regression. I told you two types of regression is linear and multilinear. Linear or multilinear. In the linear, we are having only one dependent variable. Okay, single independent and single dependent. You can say only one feature. And in the case of multilinear, we are having multiple independent variables. Or you can say multiple features, more features. Like I can give you one example, like you just want to predict the salary of professors on the basis of experience. So in case of this, we are having experience. On the basis of experience, we are predicting salary. Only one feature. But sometimes what happens, you also consider their age, their reason. There are lots of features you are considering. That time you can say multilinear. More than one independent variable is using to predicting some numerical value, then we can say multilinear regression. No, there would be only one line. In the multilinear, I can tell you, like we will see one equation, linear regression we have seen. For the multi-regression, we will see the equation y is equal to ax plus a1x1, a2x2, a3x3 plus b. So here what happens? We are having multiple independent variable x1, x2 and x3. 3 independent variable. Okay, and this output should be 1. So 1 dependent variable. And this is constant, or you can say intercept. Intercept of line, and these a1, a2 and a3 are coefficients. Clear? Line would be like this. Y is called the label. X is the feature and Y is label, or you can say output. Label which we are going to predict. Feature and parameter is same thing. Some people call it a parameter, some people call it features. So basically this is feature, means this is basically property of a object, or you can say property of data set. On the basis of these property, model will learn. Yeah, for the multilinear, it won't be the line. Multilinear means there would be some geometry. Some plane, something like this. Okay? So this is the basic concept. Now we will see one example of linear regression. And then what we are going to do, steps we are follow here. We take in the ML algorithm, like linear regression, we are going to write here linear regression. So first what we will take some data. That data having certain features or labels. And label y, and this represents x. Then we will clean this data and we will see what is inside the data. According to this, we prepare our model, and we prepare the model with the help of Sklearn. Okay, so I'll tell you what is the Sklearn and how we will work with the Sklearn. After preparing the model, we will predict output, and we also, in the 5th step, we will see it's a accuracy, or you can call it cost. So I'll tell you about the accuracy and cost also. Just don't worry about this right now. see one example of independent multilinear regression also, but right now first understand the linear regression. Then only we will move towards the multilinear. Okay? So I think now concept is clear. Let me go ahead and let me start algorithm. So here you can see the reference notes we have provided. You can open a description of the video and you can see there is reference notes for supervised machine learning regression is available. So you can see there are two types of supervised machine learning. One is the regression, one is the classification. Till now I have told you only about the regression. Classification just you don't know about the classification, just leave it. Okay, and then in the regression you can say regression is a type of supervised machine learning. It is used to predict the relationship between dependent and independent variables. Okay, what are the types of regression? There are the different type of regression: linear regression, logistic regression, polynomial, stepwise, rigid, lasso and elastic. Right now we are only seeing the linear regression. In the next upcoming classes, we will see other regression also. So just focus on the linear regression. In the linear regression is probably the simplest approach. Yes, we learned the classification later. Yes, these reference notes will be lifetime. You visit our website www.goeduhub.com and there would be always free tutorials available. Like here you can go to the free tutorial, you can click here and after going this, you can see scroll down and then you can see here machine learning. And in the machine learning, you can see all the topics are available. Okay? In the machine learning, all the topics are available and you can click over the supervised machine learning intro. So this is the first algorithm that I am teaching you today. Okay? So basic thing is this, and linear regression. I already told you the basic concept of the linear regression. It is the simplest approach. And here you can see output is, we are going to predict some output that is the numerical value, or you can say a continuous number. What are we are trying to do? We are trying to fit a best fit line. Like here we having independent variable and dependent variable and certain data points. We just want to fit a best fit line like this blue line, and on this line if you see a value, a red point meeting, where red point is meeting here. So this point should be as near this line. Okay? So what we are going to do? Let's assume we have only one variable and one target. Then linear regression is expressed like this: y is equal to ax plus b. I already told you. For x we are calling this independent variable, or sometimes we call it predictor also. Y we are calling it dependent variable and sometimes we call it predicted. Okay? And a and b are the coefficients. And when working the linear regression, our main goal is find to best fit line. Okay, so calculate this. After creating a model, we are going to see it's an error, how predicted value should be and what our model is giving you. So our model is giving you some, like in your estimate, a fruit name should be banana, but your model is giving you a fruit. You cannot say the name, let me tell you, just wait. Like a simple example, a stock price. Okay. In this stock price, you trained your model and you know output should be 10, but your model is giving you 8. So this is 8 is predicted value and this actual value you already know. Okay. So what we will do in the cost or error? In the error, we will actual value minus predicted value. This is basically error. But here, what the formula we are applying, we are doing the square of this and then dividing by the 2. So you can see here, Basically error is predicted value minus true value. But we are doing the square of the error. Okay? So why we are doing the square of the error? Because sometimes what happen, your predicted value can be more and sometimes predicted value can be less. Like here, your predicted value, sometimes it is 8 and sometimes it is 12. So difference is only the 2. But when we are subtracting, it is affecting more. Like 10 minus 8 is 2. But 10 minus 12 is minus 2. So this minus 2 doesn't matter. So what we are doing its square. Okay? Yes, there are the different formulas, but one of the way is square of the error. That's why there are different type of errors, mean square errors and mean sum errors. There are lots of type of errors that also we will see, but right now I'm telling you how we are calculating the error. Basically error is predicted value minus true value. Okay? So squaring the error penalize the large difference and minimize the square errors guarantees a better model. Yes, different type of errors we will see, but right now I am telling you why we are doing the square of the error. Sometimes it's positive value, sometimes it's a negative value, but negative value difference is in the negative range and it affect the model performance. So always we need a positive value. And we need to, what we are doing here, we are getting the error. First time, suppose we are getting 30% error. We need to reduce this error. We need to reduce this error. So what we can do to reducing this error, we can train our model again and again by changing the value of A and B. Okay, you have X fixed, but what you are changing here? A and B. How we can change? We can change A and B with the help of gradient descent. Okay, so we will try different combination of A and B, and at the end when we are getting the very less error, that time we can say our model is working fine. Okay, so this is the basic concept of linear regression. So gradient descent is to update A and B value in order to reduce the cost function. This is very important, guys. And achieving the base fit line model uses gradient descent. The idea is to start with the random value. Initially, we will start A and B value is random. Then iteratively we will update the values and reaching to the minimum cost. Okay, here I am telling you square error. Okay, there are the other methods also, mean error, but I am telling you the square error. That's why here we need to do the square. Okay, now we will do one example in the class. You need to download this data set. Click here. We will implement the simple linear regression. Then you will get the more idea. Like when we are doing something, some implementation, then you will get the more clear idea about the algorithm. So you need to click here. You need to download this data set. Okay, salary data set. Salary data.csv. Yes, I am taking the practical example. Don't worry about all these things. Cost is basically error. Please go to the website. You can see the reference notes. In the description of YouTube video, you can see the reference notes. There is the link available for this data set. Coast function is basically error, nothing else. Okay? Some people are asking, please repeat again. Error is nothing, it's basically predicted value minus actual value. Let me tell you one more time, don't worry guys. And otherwise you will see the practical example more clearly, but still. Predicted minus actual value. That is the error, or we call it coast. Okay? How far our line is from actual data? Like what should be the output and what our model is giving the output. The difference between both is called the error. Okay? So what happens, we don't need the negative difference. Like here, we are predicting for 10 records. Okay? So 10 records we are predicting, so their actual value, we will sum their cost, sum of cost. Okay? So for every value, like if actual value is 10, our model is providing 8, actual value is 11, our model is giving 9, actual value is 15, our model is giving 40. So what we are doing, difference and then square of these values and then sum of all these values. This is the formula. There are the certain formulas. We are doing the square, then sometimes we are, in some errors we are dividing by n, in some errors we are dividing by 2. So don't worry about all this. Basically understand this concept. Error is difference of prediction minus actual. And then we manipulated different type of errors. So different type of functions created to get the best output. Okay? And what is the gradient descent? Gradient descent is like y is equal to ax plus b. You are having fixed value is x. Inputs, your inputs are fixed. What is variable here? Variable is a and b. So initially we will take some random value for a and b. Okay? Random value, and then we will check its error, and if its error is more and less, we change a and b values. Okay? So iteratively we change a and b values. We will update a and b to reduce the error. So this task who will do? Gradient will do. Actual minus predicted or predicted minus actual, doesn't matter. Okay? Now we will do practical part. Okay? Guys, please download the data set and open your Google Colab, and now we are going to explore how to implement the linear regression. Okay? So open Google Colab. And new notebook. Okay, you need to download the data set, guys. Please see the reference notes below the YouTube video, and there is a link of this article. You need to scroll down, and here at the last, simple linear regression download data. Click here. If you click here, you will be redirected to a CSV file. Download this CSV file. Okay, and then open a Google Colab, and here we are going to read this data set, and we are going to use even NumPy, Pandas, Matplotlib and Sklearn, all 3-4 libraries, and one algorithm we are going to implement, that is the linear regression. So one more thing I'll tell you, Sklearn. If you put the Sklearn Python, its documentation will appear. Yes, sklearn.org. You can go to here and you can see there are lots of things, like we are having data sets, we are having certain algorithms. It's still opening, just wait. Sklearn.org is not opening. It will open, don't worry. And we are having lots of things inside this. Okay, so first of all, you need to download the dataset. You already downloaded dataset in the Google Colab. In the left side, you can see this files icon, and you need to click here, and then you need to upload a file. Sklearn. Yes, this is the documentation. Okay, Sklearn. So Sklearn, or we call it Sklearn also, both are the same, but the documentation URL is sklearn.org. So here you can see this is machine learning in Python. This is the simple library generally used for implementing the machine learning algorithms. Okay, simple and efficient tool for predictive data analysis, accessible to everybody, and built in NumPy, SciPy and Matplotlib, and open source. So we can use this library. And here you can see they have built certain examples for their classification, regression and clustering. So what we are saying here, we are saying regression. So let me open the regression, and in the regression you can see the linear models. There are lots of things are available. Okay, so I just want to tell you, this is the algorithm, this is basically library that we are going to use. Data sets also available here. You can click over the data set, and then you can see lots of data sets are available. In the left side, example based on real world data sets, or otherwise you can search Sklearn data set, it will give you data sets. Okay, and it will redirect you stable data set loading utilities, and then you can see here toy data sets, and then you can see load underscore Boston, load underscore iris, load underscore diabetes digits. These are the data sets inbuilt inside the Sklearn. Okay, in the description of YouTube video you can see the reference notes. If you click over that, you can see data set. Otherwise just visit GoEd, you have free tutorial, and then go to the machine learning. You guys should be used to this website. Till now we have seen lots of classes over the machine learning, and then all the topics are here. And if I click over this supervised machine learning introduction and scroll down, you will get the data set here. Click here. Okay. So next thing is I need to upload the data set in the Google Colab. Click here and you need to upload the salary data. Okay, my data is already uploaded. Now I need to import this data set. Okay, so let me close this, and here I'm going to write, I'm going to import certain libraries. How to read the data set? I'll read the data set with the help of Pandas. Okay, and I'm going to use certain libraries. So first of all, I'll import necessary libraries. Okay, so you can see here import numpy is np. That's why in the last classes I already told you these libraries are very important, guys. Please focus on these libraries. Okay, is pd, and then import matplotlib is matplotlib dot pyplot is plt. Okay, and let me run this block. Now I'll import the data set. I'll read the data set. So you can say import data set. And here, how to read the data with the help of Pandas. We are having a CSV file, so we can use read underscore CSV function. So you can write this data set equals to pd dot read underscore CSV, and then you can give the name of the file as it is. Whatever the name you are having, you need to put as it is. Salary.data.csv. Either you can right click and you can copy path. So it will pick the name along with path. Okay, you can write directly without the content also. Colab will work. So pd dot read underscore CSV salary data.csv. And then I'll print this data set. Clear everything? Again, I'll repeat all these things. First, download the data set, because this is very important. Without the data set, you cannot do anything. So click here, download the data set, and then in the left side, you can see all these icons are available. This files icon, click over this files icon, and then you can see this up arrow, upload to the session storage. Click over this upload arrow, and then here select your file wherever you are having the file in downloads or some other location. You need to click over the file and then open. It will upload the file here. You can see the name of the file. Then close this, and you need to import the necessary libraries like numpy, pandas, matplotlib, and then you need to read the data. So dataset equals to pd dot read underscore CSV, and here you need to put the name of the CSV file. Clear? And then you can see print data set. You can see this data set. I already opened this CSV file. This CSV file having years of experience as well as salary. So you can see we are having two columns only. One is the years of experience, another is salary. So on the basis of years of experience, we are going to predict salary. Okay? Years of experience, you are having input is years of experience and output is salary. So somebody having years of experience 3 is getting the salary 60,150, and somebody having the experience 4 year is getting salary like this. So basically we train our model with the help of these two things, years of experience with salary. And we divide this data into two parts, training and testing. So like you can see total records, how many records we are having? Around 31. So we will divide this data into 275 ratio 25, or you can say 80 to 20. Okay. So we need to read this data set and then you can print the data set. Here also you can see we are getting in this data frame. This is basically data frame. In this data frame we are getting two columns. One is years of experience, another one is salary. So years of experience is like this and salary is corresponding. So this years of experience you call it independent variable or you call it X. And your Y is salary, that is dependent variable. On the basis of years experience, you are predicting salary. Okay. So here we are having two variables, X and Y. And you can call it years of experience is feature and the salary is label or output. Okay. So shall I go ahead? I can also check this data set like df.head. Like this is very small file, but sometime what happen, we are having big data set. So what we are doing here, data set dot head. Head will give you top 5 records. So with the help of head, you can see what is inside my data. Even I can check the type of the data set that I think we have done this exercise in the Pandas, but still I'll do one more time for you guys. Print and then type, and inside the type I'll pass data set. Okay, so this is Pandas data frame. And top values we can see with the help of head, and similarly the bottom values if you want to see, you can see with the help of tail. Okay. Now what we can do next, we can see some statistics of this data, or we can check how many columns. Simple things I'm telling you, data set dot columns, you can check the data set dot columns. So here the columns is 2 columns, years of experience and salary. Clear? I can also check data set. These are the properties I'm using from Pandas. So data set dot shape. Shape will give you number of rows as well as number of columns. So here we are having 30 rows and 2 columns. Clear? All are doing along with me? Okay, I'm going slowly, don't worry. One more time I'll tell you what I have done. Simply read the data set that you already know, pd.read_csv, then print the data set, and then you can check the dataset.head, top 5 records. This is small file, that's why you know it have the 30 record, but sometime what happened, we are having thousands of records, lakhs of records. For that we are using head and tail. Okay, so here you can see dataset.head is 5. It will give you top 5 records. And then you can check the type of this data set. Type, we will pass through the type function. It will give you Pandas data frame, because we already read this file with the help of Pandas data frame. Guys, please follow the class. Okay. And then dataset.tell. Simple, I have read the data, nothing else. If you followed the last classes, then there is nothing new I'm doing here. Simply I'm reading the CSV file with the help of Pandas. Again, people are asking, repeat. Okay. Simple thing, nothing more. Simple reading a file, then I'm checking it's a type, head, tail, and then you can see number of columns, dot step. Please follow the last classes also. If you complete the last classes, then this class is very easy for you. Yeah. Okay. Next thing is what we can do. Dataset information we can check. There is lots of functions inside the Pandas. So dataset.info. You can check this also. This is a simple function inside the Pandas. So you can see here we are having two columns, years of experience, salary, and not null. There is no null value. Data type is float 64. Okay, and index range 30 entries 0 to 29. All these things are about our data set. Nothing new. We are having a file, and inside that file we are having 30 records only. That's why you see this is very simple thing I'm doing, but if you are having a big file, then you should do all these calculations. Then only you will get idea about the data. Okay, so you can see dataset dot min. Minimum value I can see. Minimum value is this, years of experience 1, and corresponding salary is this. Similarly, I can see maximum value. Even I can see statistics also. Okay, dataset.describe. I can call this function also dataset.describe. Okay. Sorry. Minimum and maximum values, and then describe, it will give you the statistics. Simple statistics, count, mean, standard deviation, minimum 25%, 50, 75%, and maximum. Okay, and we can also use LOC, ILOC functions. We can check the unique values also. I'm repeating all these things because it will clear your concept of Pandas. ILOC. Dataset.ILOC. If I'll write here something 2 to 6, means it will give you second to 6th row, not the complete data. You want subset from the data, from somewhere in between. Okay, so simple thing. First we are doing very simple example. Then we will move towards some complex data sets, and like some data set having some missing values. We need to treat all these things. We need to clean the data set, and if our data set having lots of things like it is having some string values in the columns, we need to remove those, or either we need to convert values into the integer. Because the machine learning algorithm, if we are teaching algorithm, it means we need to feed some numerical values only. Okay, so you can see here, like we can also check the correlation. Somebody have written a function correlation. So dataset dot correlation. Okay, it will give you the output like this. What is the relation between data set, like years of experience and salary? Correlation 1 means it's a relation with itself is maximum. Okay. A variable having relation with itself is maximum value, that is the one. But here you can see years of experience having relation with salary is 0.97, 97% you can say. Okay. So this is the correlation, and like in the correlation, sometimes some features don't have any relation, correlation is very less, then we can eliminate those features. That thing we will do in the feature engineering. Okay, so basically what we are seeing, we are checking the statistics about the data, how our data look like, what is inside our data file, how we are going to treat this data. If you know more information about the data, then only you will create good algorithms. This analyzing data part is very important when you are creating some algorithm. Yes, we can remove some features also. Like this is very simple data set. I am taking only one feature, so here I cannot delete some feature. But in the future, I'll take certain examples. In those examples, I'll remove certain features also. And either if my one feature having some like name of the cities, some string values, that either I have to convert into the numerical value or I have to remove that column, because string doesn't mean. Okay, correlation is basically dependency of one variable to another variable. How years of experience affecting to the salary. Okay. You can also check like unique data sets, like data set dot n unique. You can see this function also. Years of experience is 28 unique and salary is 30 unique. So how much records are unique? Even we can see the visualization of years of experience with respect to the salary. Let me write here. First understand the data completely, then I'll divide data into two parts and then I'll create an algorithm. Okay? So visualization using scatter plot. Okay, so here I'm having two things inside this data set. One is years of experience, so I can put like this data set and then single quotes and then years of experience. And second parameter, what I am having, data set, and then you can write salary. Sorry, SALARY. Okay, S should be capital. Two variables I'm having. Now simple plot with the help of matplotlib plt.scatter. Okay, and inside this, or I can put like this, x equals to this and y equals to this. So plt.scatter x comma y. Okay, and I can give the color equals to red points, and then I can also provide the marker also. Marker is plus. Okay, and then plt.show. And these are the points. Let me write x label and y label also. plt dot xlabel. Xlabel is years of experience. Okay, and plt dot ylabel is salary. Okay, let me run this, and you can see this graph. This is years of experience and this is salary. Suppose someone having years of experience too, salary would be near about something 42 or 43,000. And somebody having years of experience is 2.3 something, its salary is 41,000. So this is basically data set we are having. Dependency on the basis of years of experience to the salary. Clear? This is basically statistics about your data. Guys, just wait. I'll take all these things, like somebody asking about the heat map. Don't worry about all these things. In the day one, you cannot learn all these things. In the day one, just try to learn a simple example as simple you want. Marker is basically point. Yeah, that is the correct question. What is the marker? Marker is this point. This point. Okay? Simple. Now I'll divide my data into two parts. Dividing data into X and test and train. Let me write here. You can say splitting of data set into testing and training. Here we are going to use Sklearn. Import Sklearn. Okay? And from the Sklearn, I'm going to import model. Model selection, and from the model selection there is a function train underscore test underscore split. Let me first write, then I'll explain you. From Sklearn dot model underscore selection import train underscore test underscore split. Okay, this is a function used to divide data into training and testing part. Okay, now I'll use this function. Clear? Here how this function works. Okay, train underscore test underscore split. Some problems, connection is successfully reconnected. We are okay. So you can see here train test split. We are having X and Y two things. Okay, in the X and Y, train and test. This should be in training and this should be in the testing. And Y also train and test. Okay? Train and test. Basically, we are having two variables x and y, and we need to divide x into two parts, training and testing. You can say this will divide your data into two parts, training and testing. What we need? We need x into training and y into training. Okay, so x train as well as corresponding y train. Similarly, x test and corresponding y test. Like you are having total 30 records. Out of 30, you divided this 30 into like 20 or 10. So in 20, we are having x and y both. X and y, and here also x and y. So this 20 is for training and this 10 is for testing. Okay? So basically we are having total 30 records and then we are dividing into two parts, 20 and 10. So this 20 having x and y. And similarly this 10 also having x and y. So from the 20, x is x train and y is y train. And from the 10, x is x test and y is y test. Like here, I told you in the years of experience, we will take this example, our years of experience here, this data set. This data set having 30 records. And I need to train my model, so I need to divide this data into two parts, training and testing. So suppose these 20 records I have taken for the training. So out of 20 training, we are having two things. One is the x and one is the y. So we call x train and y train. Similarly, remaining 10 records we are putting for the testing. So in the test data also, we are having x as well as y. So x test and y test. We are having 4 variables. Okay? So basically simple thing here, I need to write 4 variables. X train, okay, y train, x test, y test. Okay, 4 variables we need to put x train, x test, y train, y test equals to train underscore test underscore split. Now inside this we need to put variable names. So our data, what data we are having? We are having 2 things, data set. So inside the X we are having years of experience and inside the Y we are having salary. So I'll take X and Y. Okay, what we are splitting? X and Y. So here X comma Y. Now I need to provide the test set like 30%. I just want to put into the test set. So test underscore size equals to 1/3. And then one more parameter I'm putting here, random state. Random state, you can put any value. Like here I'm putting 1. Let me tell you again, just focus on the class guys, train test split. How this function works. This function is very important, okay, and this is inside the Sklearn. Okay, you can search Sklearn train test split. Okay, and you can see this function, like what input this function takes. Okay, train test split, and inside this function train test split we need to provide our x, y, test side and random state. We need to give the 4 parameters. Let me explain again these 4 parameters. What is the 4 parameters? Basically x is x is our features. Inside the x we are having features. Here we are having only one feature, that is the years of experience. Why we are having label output that we are going to predict. So x and y should be clear. This test size is how much data you want to put into the test. Remaining data will go inside the train. So 1/3 data will be in the test and 2/3 data will be in train. Clear? Third parameter. Then fourth parameter, random state. What is the random state means? This random state is basically for reproducing same data set of train and test data. Like what happens once I run this function? Out of 30 records, first 20 record will go into the training and remaining 10 record will go into the testing. Next time again I'll run this program and last 20 records will go into the training and first 10 records will go into the testing. What happens here? Training and testing data is changing again and again. Random state. Let me explain you random state. Random state. Total we are having 30 records. Out of 30, 20 in training. Okay, and 10 in testing. And out of training we are having x and y, x train and y train, x test and y test. Okay, clear? Now I want every time these 20 records should pick, like whatever the 20 record, first time it is picking same index record, always this algorithm picks for the training. If I don't write random state is not there. So what happens, like from first index to 20th index, first time it will pick for the training. First time. Again, after some time, I'll run this algorithm and some middle, like from 10th to 30th index, it will assign to the training in the second time. Third time, it may be some 5th to 25th. For the training, every time training and testing data set, order is changing. It is picking different index data set. Okay? So what happens, our algorithm will learn, first time it is learning from different data set, second time it is learning from different data set. So accuracy will affect. Every time it will give you the different accuracy. And what the random state will do? Random state will do every time same index data it will pick for train and same for the test. So I can define like this. Every time I just want to reproduce same data set. Reproduce same data set for train and test. This is basically I want from random state. You can put any value for the random state. Like either you can put 1, 2, 50, 0, whatever you want. But you need to put this parameter and you need to give some value to the random state. So if you are putting this parameter, it means this function always picks same index data for the train and same index data for the test. You run this program anytime, like n times you run this program, this will pick same data set for the training and same data set for the testing. Okay, we can give any value to the random data state, random state. Clear, guys? Any value you can give, 100, 200, whatever you want, you can give the random state. Even you can see this documentation also. Like from the Sklearn, yes, here random state is equal to 42 and this random state means somewhere they have, yes, random state. This random state controls the shuffling applied to the data before applying to the split. Pass an integer for reproducible output across multiple functions. I think now it should be clear to you. What is the random state? Guys, can you please give me confirmation in the chat window, like it is clear or not? Shall I need to tell you again? Yes, random state means you can give any value and it will take the integer value, okay, and it produce the same data sets. You can say same index every time. It will pick the same index for the training data set and testing data set. (30-40) I have taken the simple example. 30-40 doesn't matter. This is the simple example I have taken. Like total data set is 30 record, having 30 record. It can be n number of records. N records. This 30-20 is depending on the test size. Like one parameter we are providing, test size. Test size here I have given 1/3. Means I want to, out of total data, I want 1/3 for the testing and 2/3 for the training. That also we are providing. I think positive value, we are always picking the positive value. I don't know negative value. You can see the documentation. They have given even the integer value. So just take the positive value. This parameter is deciding how much records is going to the training and how much record is going to the testing. Like I have taken one example, suppose 30 out of 30, 20 and 10 that I have simply taken, but it depends on the how much data you are having. Like 1 lakh records you are having, out of 1 lakh, 1/3 will go to the test and 2/3 will go to the train. If you don't give the random state, then what happens every time it will pick the random data for the training and random data for the testing and your accuracy will affect. Okay. So if you are getting these things, guys, please hit the thumbs up button. Okay, and let me run this block. Now I'm executing this block. Now we have divided our data into 2 parts. Okay, let me create my model. Simple linear model. I'll create simple linear model. Okay. This linear model basically we are picking from Sklearn. From Sklearn dot linear underscore model. You can see here in the help, linear underscore model. From Sklearn linear underscore model, I'm importing linear regression. Okay, linear regression. And then what I will write, you can take any variable, like here I am taking a variable model. Model equals to linear regression. Okay, this will create a linear regression model. Okay, like basically what it will do this task, this line equation. It will solve your ax plus b. This work this function will do. It will create a linear regression model. And then we need to fit our data to this model. Okay, so model dot fit, there is a function called fit. Inside this we need to put x train and y train. What we need to give the model? X train and y train. Okay, x train and y train. Yeah, let me tell you the thing. X train and y train, there is some error, I'll change it. Basically first try to understand what I am picking here. Sklearn.linear model, import linear regression. Here also you can see the models. Linear model, if you search in place of this, linear regression. Okay, let me tell you the function. I'm preferring the documentation because it will clear your doubt also. So from Sklearn linear model, import linear regression. This is the standard function. I'm picking from linear model from the Sklearn. And then this is the standard procedure, like I need to import this function and then I just want to fit my data set. Yes, without this Sklearn we can simply write, I'll tell you that also. But first you need to understand we are going to use this library. We don't need to do the manual things. Okay. So simple is linear regression and then fit x train and y train. Okay. Then what happens, what the x train and y train is expected, here you can see the error. And you can read this error. This error means expected 2D array but got the 1D array. So we need to reshape it. You can check out what is inside the x train. Let me write here. X train. X train dot shape. This is 20, means it is one dimensional. I want 2 dimensional. Basically this model wants 2 dimensional data. Okay. So for that we need to change the dimension. We need to reshape the data. Here your reshape function will used. Or otherwise what you can do, you can write like this. Like x, I have, where is my x? Yes, this years of experience. I'm picking in the x years of experience. So in place of this, I can pick like this, 2 dimension. I want 2 dimension. So all the rows, okay, and then I want first column. So except last column, I want all the columns. Okay, and dot values. This will convert to the NumPy, two-dimensional NumPy array. And same thing I'll do with the salary also. Okay, colon, all the rows I want which one? First column. Dot values. I want this thing. Okay, I'll write this here. What I will do? Inside the data set, I am having total data. From the total data, I am picking, except the last column, I am picking for the features, that is the X. It may be more than one feature. Okay, so except the last, I am taking all the columns. Here only two columns, 0 and 1, so it will take the only 0th column. But two-dimensional, we are giving here 2 dimension, that's why it would be converted to the 2 dimension, and then I have converted to the NumPy array. Similarly for the Y also. Okay, and this thing not here, before the splitting I need to do here. Before the splitting I need to do, and then I'll split my data. X and Y something. What? Let me run again from the starting. Something wrong is data set. I'll read. This is my data set. Okay, and then I need to run. This is visualization, values, data set, colon -1 dot values. Something wrong inside this. What? Data set is don't have. Okay, okay, values. Yeah, I forgotten. This one. Hopefully this will work. No. Dataset dot ILOC. Out of my mind, ILOC and dot ILOC, and now yes, now it's perfect, hopefully. Yes, it's working. Let me again write this. I'll tell you one more time, just wait a minute. Okay, just wait a minute guys. ILOC is just for accessing the elements, just accessing the elements in data frame. So what I am doing here, total data set is this, and from this data set I want all the rows comma, column I want except the last column. And then I have converted this to the NumPy array, because whatever the operation we are going to do in the Sklearn, we are using NumPy array as an input. Okay, so dataset.iloc, and we want the 2D array. That's why we are using here iloc, and we are providing row, comma, column. iloc will give you any index, like you want some data by index. You don't know the column name. You want data by the index 0, 1, 2, 3, something like this. Okay, let me show you x and y. Print x. Then clear, more clear. X is having 2D array and it is having years of experience. Similarly, y is also having 2D array. Print y. Y is x and y is 1D array, because it is output. Output can be in 1D array, but features can be more than one. Guys, just wait. Let me explain you here. Okay, I'll explain you one more time what we are doing. Basically, we are having data set. Two things, experience on, second thing is salary. Don't confuse experience and salary. So our data set is having two things. It is a data frame. Data frame having two things, like certain rows and two columns. One is experience and another one is salary. 0, 1, 2, 30, 29. 30 rows we are having. Now what I am doing here, I just want to convert this data frame into NumPy array and dividing data in form of x and y. So in the x, what I want except the last column. Except the last column. So I just want to access with the help of indexes. I don't know the column names. So what I will write here, dataset dot iloc. And inside the iloc, I'll put here rows and columns. So rows, I want how many rows? All the rows. And column, I don't want the last column. All other columns I want in the x. So here colon -1 means started from 0 and will go till the last. It won't include the last. So this part I am putting into the x. And inside the y I am putting dataset dot iloc, and then I want all the rows and column. Which column I want? Last column. So it is data frame. Then I just want to convert into the NumPy array. So I will put dot values. Dot values. This is 2D array and this is 1D array. Why 2D array? We can have more than one feature. Here we are having only one feature, but it can be more than one feature. So always when we are fitting our data to a model, it wants 2D array, x as a 2D array. And y can be 1D array. Got it? Clear? Last column is always your label. This last column is always label. In a data set, you are having certain columns, and first column, starting columns are features, and last column is always your label, what you are going to predict. Here in this case, we are having two columns. So this last column is basically output, why we are going to predict label. Okay. So basically what we have done, we simply converted x and y into numpy array. Clear? After converting this numpy array, we are going to split our data set that I already explained you. Let me run this again. This will divide your x and y into 4 variables. Variable name can be anything. You can give any name, but you should understand their meaning. Always first value is x train and second is y train, then x test and y test. Sequence is like this. Variable name you can put x1, x2, y1, x2, y2, something like that, whatever you want. Okay. Alex is asking a question, why the x is 2D array and y is 1D array. You can see here in the y we are having only one column. We not provided slices here, only one column. Deep, nothing is wrong. Okay, Deep is telling me, I think, about this. Okay, x train, yeah, that is x train order. Okay, yes, x train and then x test, control x. X train, x test, y train, y test. Yeah, initially both x, because here we are writing x first. So first both the x and then both y. Yes, that's good. X train, x test, y train, y test. Clear? But not correct. I'm not getting. It is very simple thing, guys. I have divided data into 2 parts, x and y. Then x and y are divided into 4 parts. X train, x test, y train, y test. That I already explained you so many times. Okay? Please after the class revise this class again, because this is very important concept. One more time I'll conclude this part. Initially we are reading the data, nothing else. Inside the data set we are having the data, then statistics we are seeing. So you don't need to worry about the statistics. But after the statistics, here the visualization, and then this part is important. We need to convert data into XY. First you understand what is the X, what is the features, and what is Y means here labels. X is features and Y is labels. Okay? And then we need to divide data into X train, X test, Y train, Y test. Okay? Yes, X train, X test, Y train, Y test. Variable name can be anything, but the order always should be the same. First X, both part the X, and then both part of Y. Okay, so let me run this, and now I'm creating a linear model, linear regression, and then I'm fitting data. Okay, this linear regression is created. Here X train and Y train. Training data set I am feeding. Okay? And then what we can do, now my model is ready. Okay, now my model is ready. I can do the prediction. So here I can write like this, prediction. Okay, for prediction, what I can do, I need to write, this is model. I'll use this function model, and there is a function for prediction is predict. Okay, and inside this I need to pass testing data. Okay, so X test. I'll pass X test. It should give you Y test. But whatever it is giving you, I'm writing here Y underscore predict. Okay, when I'm passing X test, it should give you Y test. But it is providing you Y predict. Okay, now you can see the difference between Y difference of Y underscore predict and Y test. Y test is actual and Y predict is predicted. Okay, I can print here Y underscore predict. These are the values by Y predict, and I can put here Y test. These are the actual values. You can see the difference between first value, second value, third value. So basically our model is providing this array. This is the prediction provided by our model, and these are the actual values we know. Okay, I just want to predict for a single person, like somebody having years of experience 9. I just want to predict the salary. Then how I can predict? Model dot predict, and inside this I need to pass 2D array like 9, and it will give you some value, like the person's salary would be 1,08,560, something like this. You can predict for the single value also, and you can predict for a group of values, that is the testing values. Okay, prediction is simple. You created a model. You can put this model into some variable also, like my model. Okay, now I'll run this my model. Now my variable name is my model. I can use my model for prediction. My model, and there is a already predefined function predict. Inside this we need to pass X value, features, and whatever the features you are passing, it will give you according to the Y value, or you can call it label. Okay, and then whatever the output you are achieving, that is inside the Y underscore predict, and then actual value, that should be Y test. We already know. Now I just want to predict for a single value, like somebody having years of experience 6. Okay, so 6 you can put like this, my model dot predict 6, and somebody having years of experience 6, their salary would be 81,000 something. Okay? It's a floating values. You can round it. Okay? So value is 81,000 something. Now one more thing we can see, like our model, somebody asking without this how we can do. So my model, I can check the coefficient and intercept. So my model dot COEF underscore, this is coefficient. You can see what is the coefficient. Coefficient is 9158.13. Similarly, I can check the intercept, that is the B. My model line equation, intercept underscore. These are the properties we are having inside the Sklearn. So I can check the value for the coefficient and intercept. And I can check cross check, like I can make the equation. Okay, so equation I can make like this, y is equal to mx plus c. Okay, so here what I can put, m is basically my coefficient and c is intercept. So I can put like somebody having years of experience 6, x is 6. X is, I'm taking somebody having 6 years of experience. And m here I'm having, m is my coefficient. So m I'm having this value. I'm taking this value. Okay, this is my m. M into 6, okay, plus what the value for the intercept? This value. And then you can see output. This is 81,000. And you can see my prediction also, 81,000. Mathematically, in the reverse direction, I'm proving like what the coefficient my model created, coefficient is 9158 point something and intercept is 26137 something. Then I can cross check, like if I'm taking somebody having experience of 6 years, then I can create my equation like this, m into x plus c. So my m is coefficient and c is intercept. So coefficient value I have put it here into 6 plus this value, c value. So basically this is the prediction value we are getting. Okay. One more thing, a small thing is remaining, like we can visualize our result also. We can draw a line in the result also. How to draw a line in the result? Like visualizing the training data set. Okay. Here we will plot simple scatter plot, scatter into x train, comma, y train. X train and y train. And then color I'm putting here red. Okay. And similarly I'll plot a model. Let me see plt.show. What the output we are getting. Output is points, simple points we are putting here for the training data set. Now I just want to draw a line. Line is how to draw a line, plt.plot. And then you can write like this. Inside this you can pass x train. If you are passing x train, you need to pass this x train to the model. So my model dot predict, and inside this I need to pass x train. If I'm passing inside the model x train, whatever I'm getting is prediction. Okay. And color I can give any color, or otherwise I can put empty. Let me run this. This is a line, my model line. Xtrain, ytrain, and then color. Xtrain, this xtrain, if I am passing this input to my model, whatever the output I am getting. This is the line. I hope everything is clear. Okay guys, everything is clear? Simple linear regression model I have created. What do you need to do? Same thing you can draw with the test data set also. Plotting the testing data set. If you want to plot the test data set, same thing. In place of train, you can put the test. So this is the visualization of output. I will give you one task after this class. You need to do same simple linear regression. I'll provide another data set, and same practice you guys please do again so that you will clear the things. Okay, in description of this video you will get the task. Okay, so after the class, again listen this class, do this activity again, and do this activity with another data set also. This is very basic thing. If you understand linear regression, this is very, very important. You are getting most of the things in the machine learning. Okay, so I think this is enough for today guys. Guys, please hit the like button if you are liking the things. Okay? Okay guys, thank you so much. We'll see you tomorrow. Okay? Whatever the Colab files you will get in the Udemy course, okay? So you don't need to worry all these things. Just after the class, revise the things. Okay guys, thank you so much. We'll see you tomorrow.